Imagine a total electrical blackout. It's the exact terrifying scenario we covered back in episode 6.3. Every powered communication system on this massive, 6-story steel drill ship could theoretically be completely dead. Except for one. Sound-powered telephones, which need absolutely zero external electricity to function, are still working. And that right there is the brilliant, layered thinking behind this vessel's entire communication setup. No single point of failure, ever, even in a total power loss. Welcome back to The Explainer. Today we're looking at how this floating fortress keeps everyone connected. Okay, let's dive into this. Picture that heart-stopping moment again. Main generation power is lost. The distribution system is completely dark. In that scenario, how on earth does the crew coordinate a response? How do the engineers down in the pitch-black engine control room talk to the bridge to get things back online? Section 1. 5 layers of redundancy, communication architecture. To survive a blackout, the vessel relies on a core engineering philosophy, absolutely no single point of failure. To guarantee this, the GF-1200 uses 5 completely distinct, independent communication systems. We've got the PABX, automatic telephone exchange, the dual A and B PA/GA systems, talkback intercoms, those incredible sound-powered telephones, and GMDS radio consoles. Now, you might be wondering, why not just consolidate all this into one highly efficient system? Well, no single platform can safely cover every single scenario. Different situations just demand completely different tools. Section 2. Routine calls and alarms. PABX versus PA/GA. Let's break this down from the bottom up, starting with everyday operations versus general emergencies. For routine stuff, we have the PABX system. Basically, this is the ship's own internal phone company. It automatically routes calls between extensions. It's super efficient, perfect for everyday chatter. But an emergency alert, that's a whole different ballgame. That's where the PA/GA, or public address and general alarm systems, come in. And notice it's plural. The vessel actually has 2 physically separate alarm systems, dual A and B. It's that exact same physical redundancy principle we saw with the IAS's dual fiber optic highway in episode 7.1. It ensures a single fault, like a fire in one specific zone, can never silence the ship's warnings. Beyond shipwide announcements, sometimes you need an instant, unbroken line between 2 vital locations. That's the job of the talkback intercoms. These give you direct, point-to-point, two-way communication at critical fixed stations. Think about the bridge and the engine room. When things are hitting the fan, you don't have time to dial an extension and wait for someone to pick up. You hit the talkback, and boom, you are instantly connected to the person on the other end. Section 3. The Global Distress System. Reaching the outside world. So we've got internal calls, shipwide alarms, and point-to-point chatter covered. But what happens when things go critically wrong and the crew desperately needs to reach the outside world? Enter the GMDSS, or Global Maritime Distress and Safety System. This is definitely not just a regular radio. It's an internationally standardized, highly regulated system built strictly for external distress and safety comms. It's how the GF-1000 talks to other vessels and shore stations in a crisis, using equipment that is globally recognized so that when a mayday goes out, it's heard and understood immediately. But here's the catch, and it's a big one: the human element. Having the world's best radio system means absolutely zero if the crew doesn't know how to use it under extreme pressure. GMDSS procedures are governed by strict international rules for a reason. An unfamiliar crew member fumbling with distress equipment in a real emergency costs critical response time. Rigorous, regular drills matter literally just as much as the hardware itself. Section 4. The ultimate analog backup. Beating the blackout. Now, what's really interesting about this slide is this single number, 0. Bringing it back to our total blackout scenario, when every powered system fails and maybe even the emergency generator doesn't start. How do you beat that blackout? The answer is 0. That is exactly how much external electrical power sound-powered telephones need to work. None at all. They are the ultimate blackout-proof safety net. The physics here are just brilliant. These phones don't rely on the ship's generators whatsoever. Inside the handset, there's a simple mechanical diaphragm. When you speak into it, the raw acoustic energy of your voice physically strikes that diaphragm, and that movement alone directly generates its own tiny electrical signal. It creates a communication path that doesn't care if the emergency power system is totally dead. Think of it like this. It's exactly like an old corded landline phone during a neighborhood power outage. When your cordless phones and the local cell towers completely drop off the grid, that simple corded phone, drawing its tiny bit of current straight from the line, just keeps on working. Sound-powered phones apply that exact same resilient, analog principle out in the middle of the ocean. But because they are the ultimate backup, they're almost never used in normal operations. Which brings us to a huge operational rule of thumb. Crews have to periodically check these stations. A backup system that hasn't been verified recently is a backup system you simply cannot trust when a real catastrophe hits. Section 5. The Masterclass Philosophy, Engineering Resilience. Let's zoom out for a sec and look at the big picture of this escalating hierarchy. First, you've got the PABX for routine efficiency. Step 2, the dual POP GA for vessel-wide alerting. Step 3, talkback intercoms for instant point-to-point connections. Step 4, underlying all of that, the power-independent sound-powered phone as your ultimate fallback. And finally, Step 5, the GMDS for external distress. Every single tier perfectly compensates for the vulnerabilities of the others. And that leads us to the climactic takeaway of this vessel's design philosophy. From complex fiber optic networks all the way down to a completely analog mechanical phone diaphragm, the philosophy remains exactly the same. No single failure is ever the end of the story. Every system has a backup, and that backup has a backup. It ensures the crew is absolutely always connected.
Which leaves us with a pretty fascinating thought to wrap up today's explainer. The GF12000 is an absolute marvel of redundant engineering, right? It's basically a floating fortress of failsafes. But it really makes you wonder, what other massive everyday systems in our own world rely on these exact same invisible layers of redundancy to survive catastrophic failures, without us ever even noticing? Keep that curiosity alive, and thanks so much for joining us for this explainer.